Okay, so in 5.4, there's 3 theorems that are on here, but basically we've talked about the fundamental theorem without calling it that. So let's look at this one, the mean value theorem for definite integrals. If f is continuous on this interval, so you've got this continuous function or part of a function, then at some point c that's between a and b, f of c, that means the y value of c, is equal to 1 over b minus a times the integral of that function from a to b. So it's just saying if they asked you for, bless you, for f of c, and c was in between these two x values, a and b, that you could find what f of c was by doing this. Okay? That's what the mean value theorem says. Okay? Bless you. All right. And then this big thing down here says the fundamental theorem of calculus. Okay? What it's really saying is that integration and derivatives, they're inverses of each other. They are definitely related, because what this says here is if f is continuous on a, b, then f of x, some function, is equal to the integral of this, and different, let's just say it this way. The derivative is equal to the derivative times the integral. You know, it's saying it's an inverse. You don't have to memorize that. What we're going to say is that we can figure out the integral and we can evaluate it by using this theorem. Right down here is the rest of it. And it says the integral from a to b is equal to fb minus f of a. Saying we take the integral of it, so we've gone backwards. Okay, we've gone back to the thing that the function, and we're going to evaluate it at b, and we're going to subtract it, evaluate it at a. All right, we did a little bit of that last time, didn't we? In 5.3, we're going to do it more today. That's all we're doing, actually, is using this theorem to evaluate definite integrals. Now, I showed you how to do it on the calculator. And there's nothing to stop you from doing it on the calculator on your homework, except the fact that on the test, there will be probably only 2 or 3 that you can do totally with your calculator. I will want to see you evaluate it and do the work, and the answer will be in fractions. So, yes, sir?
That's on the video showing you how to do it.
Yes, yes. So the big area problems, I will probably allow you to use your calculator on and just use the Math 9 function. But we'll talk about it during the homework. So practice. I mean, you're welcome to use that shortcut, but what you need to know that you have to do a lot of that by hand on the test. So, all right, that being said, and we did this last time. We said f of b minus f of a, usually you find the integral and then you evaluate it doing that line like that, and you have a and b there. Okay? So that's what we're going to do tonight. We're going to work several of those. Okay? Come over here. Give me some light. All right. Were you still writing, Lee? Are you sure? You're good? Okay, so maybe I need to make that a little bit bigger. All right, evaluate the integral. And we'll start out really easy. And so the integral, if we integrate this, what do we get? The integral of this. Just, okay, so you went ahead and simplified in your head. I'm going to write down 10x squared over 2 plus 9x. Okay, that's what you get when you have the integral. And you may want to have out your sheet that has the integral rules for the trig. You may need it for the trig. And you would definitely have that on the test. I will give that to you on the test. All right, so we've got to evaluate it from -2 to 0. And so what that means is you're going to plug in 0, and then you're going to plug in -2, and you're going to subtract that. So if I plug in 0 to this whole expression, what do I get?
0.
Okay, and it isn't always the case. You know, if you had e to the x and you plugged in 0, you don't get 0, you have 1. So be careful. If it's 0, fine. All right, and then we've got that, and then we've got 10 times -2 squared over 2 plus 9 times -2. Okay, so you can figure that out. Is it positive or negative? I think it's negative.
Well, for like the equation is positive.
-2 squared is positive.
And there's a negative out there. Yeah. So, -2. Okay. All right. So that was not a big deal, pretty easy. That's what we're going to do. Lisa, sure. Sure it is. Okay, any questions on that? Okay. Can I move up? See, so we're still writing?
So when you're reading that little,
This?
yeah, to the right there, 0 and the -2.
Mm-hmm.
So I just take the top number minus the.
Yes.
Okay.
Mm-hmm. Top limit, upper limit. Okay. Can I move down? All right, let's try this one. Before you start this one, I would go ahead and do the multiplication so that you get 3x squared minus 15x before you take the integral. They'll just make it easier for you because we don't have a product rule or anything like that. So what will the integral be for this one? And let's 3x cubed over 3 minus 15x squared over 2. And if you're doing that in your head or you're simplifying it, that's fine. I'm just writing it out. So we end up with x cubed minus 15x squared over 2 evaluated from 0 to 2. Yeah, sure. Does that sound better to you to do it that way?
Well, that's how I do it when I do it in my head.
Okay, like that? Sure. Okay, so when we do 0, are we going to get 0? Yeah, so I don't have to worry about that second part really. But we've got 2 cubed minus 15 halves times 2 squared, and then it'd be a minus 0. I'll just put that there. And so let's see what you come up with for the number. Mm-hmm. Yeah, negative.
Negative.
Mm-hmm, because it's 8 minus 30.
Oh, it's because I put 0 and 2.
Oh, yeah, that'll mess you up. All right, anybody else? We're good? Okay, yeah, question?
So I thought you were supposed to do like 0 and minus.
It's always upper minus lower. So this was the upper minus, it evaluated at 0.
Okay.
Up there, it was,
So like if it's 0 minus -22, that's something
if it were, yeah, but it's not.
Is it positive 22?
No, it's negative because right here you've got 8 minus 30, so that's a negative 22. And then you have it minus 0, so it doesn't change.
Okay.
If it were the other way, Lauren, if it were 0 minus that, we'd have a positive.
Okay, I got
Got it?
you.
Okay. All right. You try that one for me. I'll be writing, but you're working. It's a plain integral of a polynomial. and you will not want to try a decimal answer in MATLAB. It does want fraction answers. So if it will convert it back for you and you're doing that, that's fine. I got 56 over 3. Because what I had was 56 over 3 minus 12 plus 12. So it was 56 over 3. I don't know what you... Oh, okay. Good. Oh, that'll do it. That'll do it. All right. Are we good? All right. No, we're just using the fundamental theorem calculus. I actually don't have any. All right. What would you need to do to this one before we did it? Yeah. That would be... So you want to change any radical functions to fractional exponents. So do that before you take the integral. So then you're going to have 4x cubed over 3 plus x to the what? 3 halves divided by 3 halves. And what's that going to become? Okay, so we've got 4x cubed over 3 plus 2/3 x to the 3 halves evaluated 4 and 0. Okay, because we just flip that when we bring it up. So you don't have to worry about the 0. We are going to evaluate it at 4. And again, you're going to get a fraction. So you have 4 times 4 cubed over 3 plus 2/3 times 4 to the 3 halves. Could you do all that without a calculator? You sure could. 4 to the 3 halves, square root of 4 is 2, 2 cubed is 8. So you could do those without a calculator. But I think we should get this. Let me know if you agree. So same process over and over. When we hit trig, you're just going to need to know the trig integrals. You'll have to have some algebra going on. This next one, we have some negative exponents that we got to work with, but it's the same process over and over. Okay. All right, let's try this one. Now we're gone with the zeros. We're evaluating from 1 to 32. Okay. All right. So what's the integral of x to the negative 7/5? X to the negative 2/5, because we're adding 5/5, divided by negative 2/5. So we're going to have negative 5 halves x to the negative 2/5 evaluated 32 and 1. Oh, okay, let me go back. Yep. What do you get for 32 to the negative 2/5? What's that fraction? It's 1 over 4. And you could do that in your head. You say, what's the 5th root of 32? That's 2. 2 squared is 4. But because it's a negative fraction, it's 1 over that. So it's 1/4 minus 1 negative 3/4.
Are you doing that all at once?
Where, here? I plugged in 32 and I plugged in 1. Does that make sense, Jeremy?
Where's the Y?
So he's
okay,
kind of out here.
you took it.
Why'd
Yeah.
you put it on back?
Well, because I was going to multiply 5 halves at the end. I was going to evaluate A minus B here and then multiply. You could do it 5
You
halves
just factored
times.
out the negative 5 times.
And I think, in fact, in my notes, if anybody's looking at my notes, I think I did it the opposite way. I think I had 5 halves times this guy minus 5 halves times that. I just did it differently here. All right, are we good? Okay. All right, trig one, if you need your little sheet, you might get your sheet. Okay, couple of things that we want to note here. Whoa, we don't want that. Remember we talked about that you could pull a constant through the integral sign. So this is the same as 9 times the integral of 0 to negative pi over 6 of secant, it's freezing, secant squared x dx. So I don't have to worry about the 9, it's going to get multiplied at the end. All right, what is the integral of secant squared? Tan. Okay, so we've got 9 tan x evaluated 0. Is that a negative? Actually, is it a negative pi? It looks.
No, it's bottom negative.
Oh, it's that little s thing. It's my little summation thing. I didn't think it was because I was thinking 0 to negative. Nope, that's not working. Okay. All right. So you got to be able to get the tan of pi over 6 if you can either use your calculator or if you've got that sheet with the nice little stuff on it. 9 times the tan of pi over 6 minus, we'll do it this way, tan of 0. All right. What's the, does anybody have it? What's the tan of pi over 6? Okay. And the tan of 0 should be 0. Tan of 0? 0? Question? Oh, okay. All right. So what do we end up with? 3 square roots of 3? And that's the way they want the answer. So they don't want a decimal. They want radical, so it would be best for you to be working it that way. Okay. All right, we good? All right, what do we got here? Okay, is there an integral that works with cosecant cotan? Yeah, we can pull the 4. Do what, Drew?
Can you pull up, like, can you go up?
Can I what? Well, we'll pull. I'm looking and seeing. Oh, I'm not looking at the same sheet you've got. Let me see. So, yeah, so it would be negative cosecant, right?
Yeah.
Isn't that what we would get?
Yeah.
Yeah.
I was saying, or can you take out a negative 4? And it would be negative 2.
Well, you can't just like take out a negative 4. The negative's going to
Well,
come
and
in.
it could make it-
It will be. If you guys aren't seeing the if you're looking at this sheet is the one that, a little crazy with the little thing here. What do we say, 18? Right here, the derivative of cosecant is negative cosecant cotan. So if we're starting out with cosecant cotan and going the opposite way, it's just going to be negative cosecant. Okay, so that's what we're looking at. Okay, and we need to be back here. All right. Okay, and I need my light back. Come back here. All right. So, can we pull the 4 out and say that's 4 times the integral, and I'm going to write it this way. From 7 pi over 6 to 11 pi over 6. And we're saying that that's negative 4 cosecant theta evaluated at those angles. This is nice to have that trig sheet that has them all there for you. It's fine. I don't have those totally memorized. You know, what's the tan of 11 pi over 6? Okay, but what do we get? What do we get for cosecant? Pi over 6. What's that one? Negative 2. Okay. Minus. Sorry. So we got negative 4 times negative 2 minus, what's this one? Negative 2 as well. So what are we going to end up with? 0. Okay. Question?
It's that minus negative cosecant, and the answer is negative 10.
Well, you've got the cosecant of this, and the cosecant of this is negative 2, minus the cosecant of this, which is also negative 2. So negative 2 plus 2 is 0, times that is 0.
Okay, so you did take out negative.
How did they figure it out? I think they're looking at the chart, the trig chart that has that at the bottom. Should have all of them there. You see it? Yeah. Yeah, you could do it. All right. Okay, now I want you to look at your chart and see if you can find anything for this one. The integral of tan squared. We're looking for the integral of tan squared.
It's not on there.
So if it's not there, you want to sometimes think of rewriting it. So if you also have that trig sheet, it has some Pythagorean identities. And one of them says, does it say tan squared secant squared minus 1? Is that on there? Somebody that has the trig.
Tan squared plus 1 equals secant squared.
Okay, tan squared plus 1 equals secant squared.
It should have the same thing as that.
Okay, but what is tan squared then equal to? Secant squared minus 1. So if we rewrite the integral to be the integral of secant squared minus 1 dx, secant squared x minus 1 dx, then we can do it, because is there an integral of secant squared? Okay, so that's what you want to think about. So now we've got the integral from 0 to pi over 4 of secant squared x minus 1 dx. What's the integral of secant squared? Is it tan x? Okay, so that's tan x. What's the integral of 1? X. So So we got tan x minus x. And we're going to evaluate it from 0 to pi over 4. All right, so we've got tan of pi over 4 minus pi over 4 minus tan of 0 minus 0. Let's see what you get when you get this. You will have a pi in your answer. Okay, you don't want a number, you don't want a decimal. You will end up with an expression. What's the tan of pi over 4? So we got 1 minus pi over 4 minus, what's the tan of 0? So we just got 0 there. So that all goes away. So ultimately, let's just have that. Okay. Okay, everybody good? All right. Anybody, you're still writing. Okay. This next one, when I worked them all, I was just working them the way I would work them. And I would work this one using substitution. Use substitution. So I'm going to go ahead and throw that out. It's really in the next section, but it's not a bad idea that we go ahead and see. I'm not sure if there's a better way or another way to do it, but it occurred to me that it was kind of odd that they threw that in here. We have to do something with this sine 2x. The way you would learn it in the next section would say, let's let u equal sine x. Whoops. Sine 2x. The derivative of that, what is the derivative of let u be 2x dx. What's the derivative of that? Is it 2 dx? Okay. And do we have a 2 dx here? We don't, do we? When we do substitution, we want to look for being able to rewrite this problem so we know how to work it. We don't have a 2 dx, we have a dx. So I'm going to divide by 2 and say, okay, well then 1/2 du would be dx. This is what the whole next section is like. Okay, so what I've done is I've substituted. And so now I've got u is equal to the 2x, and 1/2 du is going to be the 2x. So I can rewrite the problem then. I've got the 1/2, which can go outside the integral. It just gets pulled through. The integral from 0 to pi over, is that a 3 or an 8? Weird. Okay. Sine u du. All right, I did all that so that now I can take the integral of sine. That's not a problem. I just couldn't take the integral of 2x, sine 2x, the way it was. We're going to come across in the next section lots of things that we cannot take the integral of unless we make some substitutions. Okay, does that kind of make sense? There's one more in this section that's like that will do that. Okay, so what do we have here? What's the integral of sine? Okay, so we've got negative 1/2 cosine. I'm going to go ahead and put my 2x back in because I can substitute. Evaluated 0 pi over 8. Okay. All right, so when you start plugging in, you have negative 1/2 times the cosine of 2 times pi over 8, right, minus cosine of 2 times 0. So what's 2 times pi over 8? Pi over 4. So what's it's the square root of 2 over 2, right? So I've got negative 1/2 times square root of 2 over 2. Whoops. What's the cosine of 0? 1. Is that making sense? Okay. How do you do this? What algebraically do I need to do to be able to do this? Common denominator. So I'm actually negative 1/2 times square root of 2 minus 2 over 2. Okay, so I've got negative square root of 2 minus 2 over 4. That should be the answer. Do what? That negative's kind of outside the fraction. Okay. And I think that's probably the format that we want in Math Lab. If you took trig and you did stuff with half angle formulas and all that, you saw a lot of these things where you had to fix square root of 2's and all of that, so that should be not too crazy. The only reason that I did this was to be able to get the integral. When I'm ready to evaluate, I'm going to put it back in, whatever my u was. Okay? All right. I'm trying to give you some where you have to, yes, sir.
On your lecture notes,
Mm-hmm.
from before, you put plus 2 instead of 19.
Did I do that? Did I put the negative up on the top with this guy and not out in the middle of the fraction on the notes? Like right here? Because in my thought, if this is negative out here, then I could leave this. But if I put it up here, then I probably, yeah, if I did that, then I probably distributed it. So I think either way, but if I want to match my notes, I can do that. Does that make sense? Either way. I think if you put it out front, you would be okay, but we can do that. Okay, number 10. Let's think about strategies for this one. That looks ugly the way it is. What could I do to make it better? Take out y's. Like, what exactly do we mean by that? You might be on the right track. Can we divide it? Okay, we can break it apart. So what's y to the 5th over y to the 4th? Y minus yeah, you want it all in one line. So that's the way I would rewrite it. Okay? And then it's pretty easy to take the integral. All right? So you guys work on that one, and let's come up with a fraction. It is, you got to do a little bit of arithmetic there. I lots of times put that last part in brackets so that I know I've got to subtract everything inside there, and it will save you on signs. It will save you some error somewhere down the line, usually. What happened to what? What do you got to do here? Okay, so what did you guys get for that fraction when you did all that inside here? Let me know when you get it. And that's fine. You do not have to do it exactly like I did it algebraically. And I was trying to show every little thing, but absolutely, you know, that's the goal, is for you to get that. Everybody good with that? These are not you need help? Where we stuck? Yes. These are not difficult, and this is really arithmetic as much as anything. It's stuff that we don't typically have to do anymore. We're usually on our calculator. But in these problems, you're going to have to do some of this by hand. Okay. Number one, you're not going to get you might get a decimal that doesn't convert back to fractions. So, okay. Anybody else have a problem? We're good? Okay. All right. We got one with e to the 3x. And I did this one on the lecture notes. If you print them or you look at them, I did it with that u substitution because that's the way I learned to do it. And I really I don't remember having the rule that we had. We had that rule where if you're taking the integral of e to the 3x, what do we put at the beginning? It's 1 over k. Remember that rule? I think it's on this thing. Let me just put it right here for a sec. Gosh, I'm getting ill looking at that craziness. Hold on.
So it'd just be e to the 3x with the antiderivative.
No.
What?
No. Where's my thing? Where's my thing? Are we there? Number 8. Sorry. Okay. I'm looking at it backwards. Oh my, doesn't that make you sick? It makes me sick. Okay. If you have e to the kx, why did it get dark? It's possessed. Okay, e to the kx. And this is what some of you missed on that one test where we had a little bit of this. It's 1 over k, so in our case it'll be 1/3 e to the 3x. Does that make sense?
Well, but you have the 3 out there anyway. So
And you're going to I know. But if you don't follow that rule, what if you didn't have that 3 out there? It would end up being 1/3. You've got to account for that. So you're right. In this case, it does cancel each other out. But that's just this problem. Okay? So I wanted us to just see that. If you look at my notes, you're going to see it differently anyway. But we'll look at it this way. All right. So if we did that, that integral is going to be 3 times 1/3 e to the 3x. Okay? And what we found that just becomes e to the 3x evaluated ln 5 and 0. Okay? So we've got e to the 3 ln 5 minus e to the 0. And you're going to be doing that one on your calculator. You should be able to. Second ln will get you the e. And so you should get 125 minus 1, which is 124. Okay. When I learned to do them, it was to let u be 3x, and you had the derivative, I mean the integral of e to the u was, you had u equals 3x. I'll put that right here, but you may not want to do that. And you didn't have 3 dx here, so you divided and you got 1/3 du equals dx. So you rewrote it. You had the 1/3 outside with the 3, which is ultimately what we ended up with. So that's in the lecture notes if you want to follow that way. This is not. This was not. All right. Okay. This looks different, but what is pi minus 1? Is that just a number? Okay, so you should be able to do that one. That's just a number. What are we going to have? If we integrate that, it's x to the pi minus 1 plus 1 over 1. And so what does that become? X to the pi. Okay. Oh. Yes, why did I not put that? Sorry. Because it's what you end up with raising it to on the top. So it's x to the pi over pi. Evaluated 8 and 3. Okay. So we have 8 to the pi over pi minus 3 to the pi over pi. All right, now they're not expecting a number. They did in math lab, I think they factored out that times 8 to the pi minus 3 to the pi. Yep. Try it on your calculator. Do 8 to the pi minus 3 to the pi, and then try 5 to the pi and see if you get the same.
Be like 8 to the second minus 3 to the second.
It's totally different. Because those are two different numbers. You know, it's not like x squared minus, you know, it's different. Okay? Everybody good? All right. Okay. Let's try this next one. It's an area problem. And, well, hello. Bless you. You need your calculator because, number one, we've got to get a picture of this. So let's get a picture of negative x squared minus 3x. Negative x squared minus 3x. And we're only talking about it from negative 6 to 4. Okay. How can we look at this particular parameter here? Okay, so if I went to the window and made negative 6 my x min and 4 my x max and hit graph. Okay. All right, if I pull this over here. Okay. All right. So this is at negative 6 and this is at 4. So we're going to this kind of came down that way and down that way. All right, we're talking about find the total area of the region between the x-axis and this graph. So, think of it that and that. And so I've got this area is between the x-axis and my graph, and this little area in here, and this area here. So how many different integrals am I going to have? 3. I got to do 3 integrals. So let's write them, and then we may do it with our calculator, but let's see. I don't know. I don't know what the answer is going to end up being. Okay, so for the first part, I'm going to call this part A and this B and this C just to keep track. So A is the integral from what to what? From -6 to -3 of, okay, and here's the deal. When you have area and you have 2 functions, do we have 2 functions? We do. This line, this x-axis, what's the name of that function as far as y equals? Okay, so this part is y equals 0. And it's always the top function minus the bottom function. So this would be 0 minus -x squared minus 3x dx. Okay, it's the top. Now what's going to be on the top here? Our original function, and we've got -0, so that's going to cancel out. That's not going to matter. So B, I really need to be writing that in blue. B is going to be from what to what? -3 to 0 of -x squared minus 3x minus 0. I'll put it in there just to be consistent. It's always top function minus bottom. And what? Okay, this is y equals 0, Lee. And here's the x squared thing. That's in blue. All right? So what's on top here? Either the y equals 0, isn't it above this one? But here, that one's above. All right, C will be from what to what? 0 to 4 of, and it really will make a difference in your answer if you don't have 0 minus that. Okay. All right. Now, do we remember how to do it in the calculator? Let's go over it. I know Jeremy was gone. Were you here, my hand? You weren't here. So let's go over this in the calculator to do that for each of these. Okay? So we'll go here, and in my lecture notes, I did it totally by hand. I just did all the plugging in, but let's see if we can do this. All right, so we're going to quit out of the picture. All right, we are going to go to math, and I think it's number 9, which is function integral. Okay, that's when we have numerical integrals, we can do this. We want to put the name of the function. So what does this minus out here do? Can I just change these signs? All right, so I'm going to have x squared minus, plus 3x, comma, because it's always the function, and then comma, the variable, so that's going to be x, comma, what's my lower limit? Comma, upper limit, -3, and then close, and hit enter. You get 22.5. Did you guys get that? Okay, so in red, I'm going to put the value of that. Or in blue. So that's what I get for that one. Now, do this one. Same thing, but you have different limits of integration, and let's do that. Math 9, but we're going to have negative x squared minus 3x, comma, x, comma, -3, comma, 0, close. Did I? Yeah, hopefully. Did you get 4.5? Okay. All right, so here we've got 4.5. I'm doing this for each because if I want the total area, I got to find 3 areas and add them together. I will let you do the last one so that you can tell me what you get there. Okay. It should be the same. The answer is going to need to be in fractions. So what would this one be in fractions? Yeah. And what would this one be? 45 halves. So now add those 3 things up. See if you can do it and get a decimal and convert back. It should go into thirds. Did you just do that, adding them up and converting them? Okay. You definitely have 1 or 2, maybe 2 of those area problems on your test, which you may use your calculator to do. You know, that's not, if you look at my lecture notes, the amount of work when you have to do all those out by hand and plug in and stuff, that gets tedious. But
What was the question asking?
it said, what is the total area of the region between the x-axis and the graph of this between -6 and 4? So what we first had to do was get a picture. So throw it in your calculator, do a little sketch, figure out the areas, then write your 3 integrals, or however many there are. It could be 1. And
You're
then,
not trying to find the inside the graph. You're trying to find
well,
the-
no, we're not.
Isn't there a way you can, like, do it to where it shows the shaded area?
It's with the, if you go to the Y.
You can do some shading things, but you're getting different pieces here. I'm not sure because yeah, I don't know.
Like,
Probably on
it'd be like-
Lucas.
It'd be like that. But I mean,
Can you
it's
do
not
that,
really
Lucas,
helpful.
on yours?
I haven't tried.
Okay, well,
Let me know.
yeah. Shading it like this, Zach, like we did up here.
Well, why did you highlight
I mean, you
underneath
can-
between the X and then like
Okay, well,
right at the minimum?
well,
Like, I understand those 2, but why is it
up here.
like B? Why
Here?
did you do that?
Okay, because it's between the x-axis and my function. Here's my function, here's the x-axis. So it's that area in there.
That's what you're trying to find.
Trying to find that and this, because x-axis and my function. And I have this line because of that. And then same thing over here, okay? All right?
On your, whenever you graph it,
Uh-huh.
besides doing it on the window, you can also do it where it says y equals. You put the -x², you put that in parentheses,
Uh-huh.
and then start another parentheses, you put the -6, second test, or second math,
Less than
less
x.
than equal to
Mm-hmm.
x, and then
And just do it there.
do it there, and it'll give you the.
It'll just give you that window. Yeah, that is another way to do it because you're putting the parameters within there. Yeah, absolutely.
So you just break it up.
Yeah, what he's saying is you could do second insert, let's put this in parentheses. And then start another one, and then you would say, oh, where, no, I did the wrong thing, sorry. Go back, delete. -6, and where's my thing? Less than or equal to x is less than or equal to.
I don't think it'll work if you do it like that.
Oh, you have to put it in 2 different ones, right? You're right. You're absolutely right.
Don't put that in parentheses.
And then, see, to me, It was just easier for me to change the window, but we'll do this just to make sure. And then x is, and then it's second math, less than or equal to, what was it, 4?
And
Okay.
you can change your, window to height.
Mm-hmm. What did you put it at that made it look? Did you change something there, or what did you change?
Yeah, change the one,
What did you make it?
just put in like a 20, -20.
Did you change the y max? Okay, to get a better view. Mm-hmm.
That's it. It's on this.
I know. Let me just. Everybody will want to know. Okay. Is that not good?
What you have to do is you have to go to the menu, and you go to analyze graph, and then you go to integral, and you do lower bound, and you click on it, and then you go to the next thing, and it just upper bound.
It's, mine's on order right
I don't
now.
see what that is.
I'm gonna ask my mom to give me.
What?
What are you gonna do?
Yeah, but
Zilch that.
that's what he's saying, that you can do it without just going to the window and changing
So his, I'm gonna, what's the?
I know, everybody will be going to get an Inspire. Okay. You're gonna be a hard. All right. Okay, this one's on you. Total area of the region between x-axis and this graph. Between 0 and 3.
We're taking, what's the guys teaching at Union Bible?
We're doing this problem.
That's what we said, x and 4.
Right. Okay. Now you changed your window, so whoa, what was that? So I always do a zoom 6 just to get back there, but then I'm going to change it here and make that 0 and 3. Maybe a zoom 4. I like that better. I did a zoom 4, which just gave me a better picture for me. I can count where it's going, so I didn't.
You should change the upper function.
Mm-hmm. Oh, no.
But you didn't, your x,
Lower,
your x values aren't right.
No, they're not. I know, I know. This is where we're talking about, from here to here. But I just couldn't see it well the other way. So that was what I wrote. So if this is your A and this is your B, integral from what to what? 0 to 2 of, which one's on top? Our thing. What's
It's the top minus curve is below it, you have to put the 0 minus.
Mm-hmm. And what you may find, Keith, is what if you had two things intersecting and you had two different functions? It's just whatever's on top. It doesn't have to be y equals 0. In these it is right now, but it wouldn't have to be. Okay? All right, so this one is from 2 to 3 of 0 minus x cubed minus 5x squared plus 6x. Okay? Now this is a crazy fraction, so I don't know that you're going to be able to do it well on the calculator. We can try and see what you get. Did you already do it? What'd you get? Oh, okay, yeah, part A is that. I got 337 over 12. Okay, perfect. I got negative.
Is 0?
I got 8 thirds. So we'll have to wait and see whether you're right or wrong. I don't know if that's the final that I got. What did we get on the second part? Say what? 5/12?
Yeah, I got 5 12. I got 9 fourths.
This is what you had? Positive or negative? Positive. I don't know what I have written here. I don't even know if this goes with my problem.
I got 37 pulses at my
All right. Does that work?